Nick from the other side of the river. Nick worked together with a couple of people whom we know very well, so we're very curious of what he does, and he does something that some members of this lab are very excited about, right? Honor, and we have spent quite a bit of time trying to get actually access to sleep data and other things. So we're really curious about what you do, and I'm gonna, if you don't mind, I told you just sort of the venues earlier. If you want, when I'm saying a few words about yourself, that will be very helpful for all of us. And thanks for coming.
Thank you. Thanks everybody for showing up in the middle of the afternoon. I am a research scientist at the MIT Media Lab. My background is in political science, and I've kind of spread my fingers out into the social sciences more broadly. And what I'm really interested in is the impact of climate change, the potential impact of climate change on society. So that's the broad form. And a little bit of background. As we're all aware here, the global mean temperature is changing, it's going up, and it's likely due to the emission trajectories that we're on that it is going to continue to go up. And I and a number of other social scientists have really started to wonder if we can try to estimate what the social costs of climate change might be. It's a very hard question, and so far we can only kind of pick at it a little bit, and that's what I'm going to talk a little bit about here. But at the core of this question is whether or not the weather and climate actually causally affect us, our social systems, what we do, our individual well-being. And it may to some of you seem like a really easy question. It may to some of you seem like a really hard question. It is a really hard question. At least I think it is. And we'll talk about why. But there's some obvious stuff first that I want to get out of the way that is kind of almost trivial to know once you understand the physical dynamics of climate change. It's likely that sea levels are going to rise, and millions of people live very close to the sea and are likely to be inundated by that. It's likely that from a lot of literature, we are going to have crop losses and reductions in yield, and potential fishery collapse due to ocean acidification, and potential for social dynamics that relate to conflict around resource scarcity. That's a little bit less certain. But what I'm really interested in is in what way do we rely on the climates that we live in and the meteorological variation that they produce for our day-to-day well-being? And if you think that our meteorological systems affect us day-to-day, and those are likely to change, then when you integrate over time and space, the day-to-day effects of climate change could actually be fairly large, both positive and negative. This literature that I'm a part of, that I work in, has started to find a lot of effects in various different places to suggest that indeed humans do causally depend on their climatic systems and the weather variation that those climatic systems produce. For example, heat stress has been shown to harm human physiological well-being, to increase fatigue if you're exposed to heat stress, to reduce the efficacy of sleep and the length of time slept. That's one of the studies that we recently published in Science Advances had to do with self-report data on people's sleep efficacy, how well they slept at night, and anomalously warm summertime temperatures. And more excitingly, more recently, we got our hands on Fitbit data, or actigraph data, and recovered basically the same functional form that we recovered from the self-report data. Unusually warm temperatures produce reductions in amount of time slept on average in the population. And interestingly, that's across about 30 different countries, tens of thousands of people across those different countries. We also did some work on physical activity patterns and the way that people respond to different temperatures with their recreational physical activity, given that going outside for a walk and doing things outside is actually a way that most humans in the US at least get their physical activity in. We find that extremely cold temperatures as well as extremely hot temperatures tend to reduce physical activity rates. Economists have done some interesting studies recently and found that exposure to heat stress reduces cognitive performance in a variety of different tasks, including test taking and standard neuropsychological tests. So this is an interesting finding. And psychologists, as well as economists and political scientists, have found a positive relationship between temperature and propensity for aggression and violence. What is emerging from this literature, from Yeah, go ahead.
These results that you presented, like from psychology and economics, are causal or just correlations?
It depends on the study. The economics results tend to be more careful in doing the causal inference on that. Some of the core results in psychology are a bit more correlational. It's a great question. We'll get into exactly that and the meat of that in a little bit. But the results that emerge from this literature across a wide variety of empirical studies seem to show that there's this nonlinear relationship with temperature and human well-being. And so what we thought of for this talk and for this question that we're going to talk about here is, could weather alter other social variables? What other ways are we affected by our exposure to meteorological conditions? Might, for example, weather alter our emotional states? If it's a nice day outside, are we happier? If it's a really nasty day outside, are we less happy? We're not the first to think about this question. It's actually a real fundamental question that relates to the human experience, how we interact with our environment as it exists outside. And people have thought about it for hundreds of years, and many people have written studies on the topic that include the terms. So we're not the first to think about the question, and as a result we thought, okay, well, given that it has had so much ink spilled about it, there must not be an easy solution. But fortunately we came across this thing called mood rings. And the use of these mood rings will tell you exactly what your emotion is like as a function of temperature. So once we found that, this study was over and we had our results. Thanks for coming. Nice meeting you all. No, it's not easy. And it's not easy for a lot of reasons. And as a result of that, the empirical evidence is pretty mixed. The initial studies on this came out of psychology, and many of them had very small sample sizes, where people they were told to go outside on a sunny day versus going outside on a cloudy day, and they found that indeed going outside on the sunny day produced massive increases in happiness, and so sun is the crucial thing for happiness. Now we know that there are file drawer bias and type M error bias related issues with those studies, and more recent studies that have tried to pull in lots of different data sources, including somewhat large data, have found somewhat more mixed results. The effect sizes have been small, they've been variable depending on specification. Some of the studies don't really employ causal inference, so they have these correlational results that are potentially biased. We'll talk more about that. But we thought, okay, what are we good at? Well, we're good at working with social media data, and we have a large corpus of it. So let's bring to bear the biggest corpus of text to try and answer this question that has been brought to bear. And we pulled over 2 billion Facebook status updates from 2009 to 2012, and over 1 billion geolocated tweets between 2014 and 2016. We then aggregate these for the purpose of this analysis that I'm going to talk about here to the 75 largest metropolitan areas. Taking a little bit of a step back, what does it mean to measure emotion? That's actually a very fundamental question for the purpose of this study, and the answer is there is no answer. There is currently a very substantial ongoing debate in affective science about, for example, whether or not emotion is even discrete or if it's continuous. Can you break down emotion into distinct categories, or is emotion more of a continuous experience? If you can break it down into discrete categories, how many and what are they? So there's no concrete answer on this, but what the practice is to typically compress affect into two broad dimensions, positive affect and negative affect. And to analyze them both, because you can conceptually have somewhat both positive affective feelings and negative affective feelings simultaneously. So that's what we're going to talk about here. Now, to move from natural language into emotion, you have to do sentiment classification. And for the purpose of this study, we use multiple different sentiment classifiers that are very common in the literature that have been fairly well validated. The results that I'm going to present here are consistent across all these classifiers. I'm going to talk about the loop results here just for consistency and simplicity. Mapping onto this corpus of text is a series of independent variables, meteorological independent variables. And we take gridded daily temperature and precipitation, which is the series that you can see here, maximum temperature in degrees Celsius and precipitation in millimeters. We also take other meteorological variables, including diurnal temperature range, cloud cover, relative humidity, because other meteorological variables might correlate with temperature and confound our estimation if we don't consider them. And now, once we have our data assembled, we move into the estimation stage. And this is where you have to be a little careful. This is just the raw data. Y-axis, positive sentiment at percentage point. X-axis, maximum temperature in degrees Celsius. There seems to be a positive and linear relationship, though small, between the raw data. And the orange dots represent 5-degree being smooths, 5-degree averages for each 5 degrees in positive sentiment. So you might uncover that, okay, maybe very cold temperatures are bad for positive sentiment in its level. But as...
Shouldn't you go down? Like, there's not just such a thing as too hot?
Yes, you would think that this would go down.
Yeah.
So what we're doing here is we're just looking at a simple level bivariate correlation. And the problem with doing that is that there are many, many spurious factors that could be biasing our inference in just the raw data. So you might have spurious correlations with secular time trends. You might have other variables that vary seasonally, correlate with temperature across the seasons, and are causal in emotion, biasing the estimate that you have on your temperature coefficient. You might have some sort of selection whereby people's characteristics get them to live in certain places that have certain climates, though they don't actually prefer temperature, and that's not in part of the reason why they selected that. So we hear this all the time, and this is a trope at this point, that correlation doesn't imply causation. So you shouldn't look at that previous graph and be concerned that it doesn't necessarily uncover what we would see, because there's all sorts of reasons for that. However, when you're careful with the data, sometimes you can recover an observational correlation in the data that you can treat as causal. But you have to be careful. And for the purpose of doing that, that's basically what the whole field of climate econometrics that I work in has been trying to do for the last decade. How do we use observational meteorological data and observational social outcomes to try to explain the causal effects of climate and meteorological systems on our outcome variables that we care about? For this, what's the causal effect of weather on sentiment? We can't recover that from that graph I just showed you. It can help to think about what we might do if we were omnipotent and could control the weather. How could we figure out whether or not, for example, hot temperatures as compared to mild temperatures affected positive sentiment? Well, we might take the 75 cities that we have in the data, and we might randomly sample from those 75 cities into 2 groups, one being hot temperatures and one being more mild or comfortable temperatures. And we would expose people in those cities to those different temperatures and then measure their sentiment. And we could then actually just take the average sentiment in those 2 different groups, compare those means, and find a causal effect of exposure to temperature on the sentiment measure that we have. So conceptually, that would be really nice. Unfortunately, we can't control the weather. Well, we actually are controlling the weather, we just don't have a control group. But we can't really run this experiment as I just talked about it. However, we can do something that is similar to it. We can observe temperature over time within the same location. And then what we can do is deconvolve potential confounds from the data. Don't worry, I'll explain what I mean here by deconvolve and what it looks like in these data series. What we then have is a remaining amount of variation in temperature that we can treat as exogenous, or as assigned outside the system, the social system that we're interested in, to our outcomes. Then we can compare an observational correlation of our outcomes with unusual temperature, or with this deconvolved temperature series, to give an estimate of the causal effect. Conceptually, what does that mean? Do you know whether today is perhaps 1 or 2 degrees warmer or 1 or 2 degrees cooler than April?
Clearly.
Cooler. Yeah.
So there is what we kind of have in terms of an expectation for what temperature should be today, and then there's a realization of what that temperature is. And that's the variation that we're going to use to identify. We're going to call that a temperature anomaly. So today is anomalously cool, perhaps, as compared to normal April, late Aprils in Boston.
But is that the right reference rate? Because, like the way I feel about it is that momentarily, and all of us who live in Boston, whether it's warm or not is not determined by what was 10 years ago in Boston at this time of the day, but what happened in the last 3 months.
That is a wonderful question. I have an answer to that question in the very last slide.
Perfect.
That is foundational to understanding human adaptation to climate change.
Perfect. Okay, because we've been adapted to this cold weather pretty badly.
That's right. That's right. Okay, so that's conceptually what we're trying for. I was born in Columbus, Ohio, so I chose Columbus, Ohio. We have a city. We have its temperature variation over time. You can see that Columbus, Ohio has a substantial amount of seasonality in temperature. Temperature on the y-axis in the left panel, date on the x-axis. And so it has seasonal variation in temperature, it has inter-day variation in temperature, it has inter-week variation in temperature. And you can also see that it has some variation in positive sentiment over time in the series that we have for the Facebook data. Somewhat secularly trending upwards over time. There's a lot of inter-day variation as well. These data are potentially confounded with all kinds of other variables that can bias our inference. One of those types of variables could be something that's constant at the city level. There could be city level cultural factors that produce different levels of affect, and that could be correlated with mean amounts of temperature. And so sometimes in the literature what you'll see is you'll see people say, well, we included city fixed effects to try and control for those confounds. But you can see clearly that there's a lot of seasonal variation that remains that could easily confound your inference if you only include city level fixed effects. And fixed effects are indicator terms that you can put in an OLS regression to effectively demean the data around those indicators. So what do you do? Well, you'd like to deconvolve out the seasonality. How do you do that? You provide city by month as well as date specific fixed effects. So you deconvolve out the seasonality and you deconvolve out date specific idiosyncratic shocks. And what you're left with is a series of variation that gets at the conceptual identification that we're interested in. Was today a little bit warmer or a little bit cooler than is normal for this place in this time? You also get that for positive sentiment. So was positive sentiment in this place a little bit higher or a little bit lower than you would expect for this place at this time? Zooming in a little bit on the variation, you can see that there is variation. Just inspecting it doesn't give you any real understanding of whether or not there's a correlation in this series. So this is what gives us causal inference. The remaining variation in temperature that I just showed, we can treat as good as randomly assigned to the social system. We're not doing anything to control the fact that the temperature today is a little bit warmer or a little bit cooler than it normally would be. And so what we have here is what we'd like to call a natural experiment. So now we have deconvolved data. And it's the same plot, except these data have been deconvolved like the series I showed. This can provide us causal inference, right here. You can causally say, if you buy my assumptions, that there is a causal relationship between unusually warm temperatures and unusually high sentiment. And it looks pretty linear if you see the smooth. But there might be heterogeneous effects in the data. If you're at freezing, if you expect to be at freezing, then it might be nice to have unusually warm temperatures. But if you're at 40 degrees Celsius or 100 degrees Fahrenheit, you really might not prefer that additional few degrees of warmer than it should be. So in order to get that, we put the deconvolved data, or we create the deconvolved data in the context of a model. And I'm just going to run through this briefly. We can talk about it more for anyone who's interested in nerding out on the stats. But again, the dependent variables, rate of positive sentiment, rate of negative sentiment, we have a series of independent variables, primarily interested in maximum temperature, but need to look at and also control for other meteorological variables. Unit analysis city day. The fixed effects that we include are the ones that we need to deconvolve the data in the way I just described. And for the real nerds, we use semi-parametric bins on 5-degree intervals, though the results are the same for 2-degree and 1-degree intervals. Cluster our errors on city and date, and weight the regression by the number of posts in that city day. What does that produce? What does the model show as a functional relationship between temperature and precipitation and our positive and negative sentiment variables? You recover from that model very much what you expected to see. Once you deconvolve the data, you then see that positive expressions increase up to between 20 and 25 degrees Celsius, 70 to 80 degrees Fahrenheit, which is kind of a nice, pleasant temperature. Negative sentiment declines to that point and then increases past it. So you have that cold temperatures and hot temperatures are not good for sentiment, and pretty much any precipitation fairly linearly harms sentiment. We just don't like it very much if it's raining outside, and that is pretty consistent. On the Twitter data, we estimate very similar functional forms. The data from Twitter are a little bit noisier. We had nicer and longer Facebook status updates that contained a bit more emotional expression. Tweets are a little bit noisier text in general and are just shorter than what we had on average. So we have a little bit more noise in those data. That's why we think the estimates are a little bit smaller, but the functional forms look very similar. Breaking out, just kind of interpreting what's going in the model, which is the result in the top frame. This is the Facebook positive sentiment result from the model, and then what we're doing conceptually with the raw data, just so you can see what we're doing with the model. On the bottom frame, which is conceptually with the raw data, we're treating each 5-degree temperature range and allowing it to have anomalous shocks. Is it warmer or cooler than you would expect within that bound of range? And you see that, indeed, when it's very cold outside, unusual increases in temperature have a positive relationship with positive sentiment. You're happier when it's warmer, when it's cold, and when it's really hot outside, you are less happy when it is warmer than you would expect it to be. Key point here that we uncovered from the model, other weather variables matter too. Increases in cloud cover and relative humidity harm sentiment, and interestingly, decreases in diurnal temperature range harm sentiment. So if the night is very similar in temperature as the day, your sentiment worsens. Perhaps because oftentimes when that happens, it's because the night is not as cool as it would normally be. So in sum, we have adverse weather harming positive sentiment, or decreasing positive sentiment and increasing negative sentiment. If you were looking at the results carefully, you might have thought, okay, look, 1 percentage point. Below freezing temperatures, 1 percentage point reduction in positive sentiment as compared to ideal temperatures. But you also might have thought, that's a little small, right? We were just complaining about it being cooler than we would expect at this part of the temperature range and that not being that great. We talked about that a good amount. It seems like it might matter more than 1 percentage point change in our mean level of affect. A key thing to note is that there's a trade-off. When I walk through the deconvolution of the data, what I'm doing is trying to pull out anything that might bias my inference, but leaving any noise that is in the data that's idiosyncratic in the data. And so I'm somewhat systematically downward biasing the size of the effects that I'm estimating because of that process. So how can I see whether or not weather matters for sentiment in a socially meaningful way? One way would be to try and identify other events, other shocks in the data that we would expect logically should and did reduce the emotion or the sentiment of a place. So that's what we do here. On the far left bar is the effect of being below freezing as compared to ideal temperatures. And what you see is across a variety of different events that we can identify in our data as shocks that should harm positive sentiment conceptually. For example, if you look at San Bernardino, in San Bernardino, on the day of the San Bernardino terrorist attack, the reduction in positive sentiment that caused is similar in magnitude in our data to the reduction in positive sentiment that being below freezing as opposed to ideal temperatures caused. So that gives us at least some qualitative understanding of potentially the societal magnitude of these shocks. It's not insignificant if other things you should think should matter a lot in the data matter on similar orders of magnitude. Okay, so those empirically minded among us probably have a lot of questions and a lot of concerns about what has happened so far, one of which is probably the ecological inference fallacy, which is I moved very quickly from text individuals are producing in discussion of individual level emotion and affect to aggregating to the city level. We look at user level results as well. We control for user level individual fixed effects and all the other confounds that we discussed. And at the user level, we return similar functions as well. The other concern that people might have is, in fact, that we just talk about the weather. But it doesn't actually affect our sentiment. I say the weather is crappy outside, but that doesn't mean that I'm less happy necessarily. And if we're picking up in all of this corpus, people just absent-mindedly talking about the weather, and they're more likely to talk about the weather when the weather is more extreme, then we may be getting an artifact that is just literally an artifact of our measurement.
Or just there's something to talk about.
There's something to talk about, and you talk about it in ways that convey sentiment, but that sentiment doesn't necessarily mean that your emotions have changed. Yeah. And so what we do is we create a weather term classifier, and we pull out tweets that relate to the weather. And doing that, you still recover very similar functional forms. So it suggests that this is not being driven solely by just talking about the weather. Another thing I did is I pulled a sleight of hand, which is I moved quickly from talking about affect to talking about, okay, we're measuring sentiment. There are a lot of reasons, in addition to the weather, why sentiment might not be a valid proxy for underlying emotional states. A lot of the data that we have is public expressions, either public to our social network or public to the broad public. And so people might not actually convey the feelings that they're feeling in the speech that they're using. They may well just obscure or censor that. Or they may be creating personas that are not actually reflective of their underlying emotions. Or they may just use terms and words that our sentiment classifiers pick up that are just orthogonal to the way that they actually feel. No one has answered this question yet. And it's a foundational question to be able to move from natural language text, measuring constructs that we're really interested in from a psychological perspective. And we don't know the answer to this yet. Fortunately, it's an empirical question we're trying to answer. And the way that we're trying to answer it is we have a series of bots and we have a series of kind of web apps that we are collecting people's rated tweets for the emotions that they felt when they tweeted their most recent tweet. We're asking you to go to you're a frequent Twitter user, we got you just on your most recent tweet. How did you feel across a variety of emotion dimensions when you wrote that tweet? Not how did that tweet, not how do you think that tweet seems, but actually how did you feel? And hopefully through this process, we have a number of thousands of tweets and we're trying to collect more. The app is called Deepmoji if anyone wants to rate their tweets. But hopefully through that process, we can kind of get a little bit more purchase on the degree to which sentiment is a valid proxy for underlying emotion. Finally, generalizability. So this is a concern with any social media data. How much am I actually estimating effects that are durable and consistent across the population? The nice thing is we had all of Facebook in 2009 and 2012. So it's representative of the population that used Facebook back then, which was a more narrow population. And unfortunately, the Twitter data that we have are from geolocated tweets. People who geolocate their tweets are weird, even when it comes to Twitter, and Twitter users probably aren't representative of the full population. So the generalizability of this to even the US population might be low. But one way you could see the degree to which these findings held elsewhere would be to look at other countries around the world, from perhaps different languages and different platforms. So we did that. And this is in prep still, but we have millions of Weibo users. And we uncover a very similar functional form in Chinese Weibo, which is like Chinese Twitter, in non-English related languages. So this seems to be a little bit more consistent than just in the US. All right, quick summary. Millions of individuals, looks like weather causally affects our sentiment. Adverse weather harms the sentiment, mild weather augments it, and the effects are relatively sizable compared to other large events that occurred in our data, and still more remains to be done. I'm going to end on this because I started on this, and that is to say, I'm interested in climate change, and we just talked a lot about the weather and meteorological events. How might that actually give any purchase in terms of understanding how climate change could impact sentiment and emotions in the future? If you make a strong assumption, which you brought up, of no adaptation, then you could expect that warming on the cold side of the distribution might improve sentiment and warming on the hot side of the distribution might harm sentiment. the climate science is less certain in terms of exactly what's going to happen and where with respect to precipitation, cloud cover, and relative humidity, so less clear inference there. But it's a strong assumption to assume that there is no adaptation. And the question there is, do people adapt, and if so, at what rate do they do? We have a paper under review now that looked at the degree to which exposure to repeated warming over time. So let's see, basically in February, I don't know if anyone remembers, but February this year we had a week where it was really warm. February last year we also had a week where it was really warm. If it is the case that February next year is really warm, then the data that we uncover and the analyses that we do suggest that we will talk about the weather a lot less than if we hadn't had 2 years previously that February be unusually warm. So it suggests that over even a few years time scale, our attentiveness to the weather at particular points in time declines with repeated exposure to unusually warm temperatures in that area. Now that doesn't tell us, there's other ways that people can potentially adapt and we're looking at. Other things that I'm interested in, for especially the purpose of this audience, is if people's sentiment changes, if their emotion changes, might that alter the way in which we communicate with one another, the frequency with which we communicate with one another, how we get together? And if that does alter our communication patterns, might that have cumulative and dynamic effects on the ties in our networks? Could long-term temperature shocks actually lead to changes in the dynamics of our networks over time? That's just another question that we'll look at. Anyway, thank you all very much for your time today. I really appreciate it, and I look forward to your questions.
Go for it, man.
So weather fronts span hundreds of miles.
That's right.
So how do you deal with the fact that the observations in different cities aren't independent?
That's a great question. So the concern is that you have spatial correlation, basically. And so we do a spatial correlation analysis using what are called Conley's standard errors, which you can basically allow for a increasing bandwidth of spatial correlation in the actual standard errors. And we see, largely because of the t-stats that we do have, the confidence intervals that you see here, the t-stats are huge. So even when you expand the boundary to 500 kilometers, you still have statistical significance around the estimate. But that's a great question, yeah.
Nick, great presentation. I noticed that you repeatedly showed that nonlinear relationship, the upside down parabola. I'm assuming, was that for Columbus, Ohio? Was that for?
Great clarification.
That maxima would change depending on where you're at, right?
Yeah. So that is the estimated maxima across the sample. That's the average controlling for all these other features, deconvolving all these other features out of the data. That's the average across the full sample of cities. It's also the same maximum we uncover when you go down to the user level as well. So it seems, basically the way that I would say that is, on average, people across the location prefer 70 to 75 degrees Fahrenheit as the ideal temperature for their sentiment. However, that's a great question, which is, do people who live in cold places have preference for colder weather?
Well, I used to live in Alaska. I've never heard anyone complain about snow. Everyone in Alaska complained about snow.
Right. So we did heterogeneous tests where we looked, for example, at northern latitudes and southern latitudes. We didn't see anything super consistent there. It becomes a little bit difficult as you do Alaska versus Florida, for example, because the weather distributions actually start to not overlap that much. But we did see pretty consistent. What was consistent across those heterogeneous estimations was that hotter temperatures relative to the distribution of that place tended to be not as good. So when it's as hot as it's ever been in Alaska, and it's a little bit warmer than that, that was not as good as lower down. So, but the reality is the estimates that we uncovered from the models were not consistent enough to really tell us any clear story as it varied by latitude.
Similar on the same question. Have you tried using multi-level framework with nested observation within cities, within region, within person? That's my question.
I have not done a multi-level model of this data. That's my answer.
Because
Well,
usually,
partly because
they can change a lot, and I think actually obviously more appropriate for this kind of analysis.
How are you deconvolving the data in that multi-level model?
I would do the same way.
Okay, so you're just talking basically about allowing individuals to have, or cities to have their own slopes.
Yeah.
Yeah, we haven't done that. And the honest answer to that is because that's not the norm in the climate econometric literature, and so we are just largely using methods that are used there. But it's a great question, and there's really no reason we shouldn't explore that. So I will put it on the to-do list to put it in the multi-level model.
Since you're a political scientist, voting behavior, right? I mean, we know it's bad whether people don't go vote.
Yep.
But is there a difference in the political affiliation in voting behavior? Do Republicans respond differently to whether from Democrats?
So it's a little bit difficult with the data that we have. We don't have any demographics with the Facebook data. We don't retain any of that. And the classifiers for political speech and geolocating people aren't amazing for the Twitter data. You can look at it though. You definitely look at it. One thing that I am looking at in a separate project is whether or not your opinions about climate change as a function of exposure to weather anomalies. So if you are skeptical of climate change, but you then receive a repeated or cumulative experience of unusually warm temperatures, does that change the valence with which you talk about climate change over the course of years? So there is some literature that suggests, for example, that rain is bad for Republicans. And they've looked just at rainfall, and there was kind of more of a correlational analysis. But there is, from the voting literature and from the turnout literature, the idea that rainfall on election day is bad for turnout on election day.
Yes, but I don't know whether that's generic.
Differential by
Yes,
ideology,
yes.
I don't know.
Just the fact that when we always have a November election, does this mean that we're biasing towards one or the other party?
Yeah, I mean, it's a pretty fascinating question. If you think that cultural variables might correlate with a desire to, respond differently to temperature here or there. Now, the thing is, because you're kind of controlling for the place's mean climate as well as the expectation around what the temperature would be on that election day anyway, it's the political ideology of a place is relatively fixed, and then you just have a temperature shock. So it's not as clear. I can't come up with good stories for why Republicans would have different cultural values that would provide heterogeneous effects along those.
Well, let me provide a correlation. When I look at your 2099 map,
Yes.
that the red part of the United States is all red, very hot.
That's right.
And the east and west coast, mostly because of the sea temperature, right? It's kind of moderate.
Indeed.
Is that a correlation with political affiliation?
It is a correlation with political affiliation.
Or there's a
I don't think there's
causation
anything
here.
causal there. Yeah. That's a very interesting question.
All right. Well, if no, one last question there, okay?
I wonder if you could look at the social cost of inaccurate predictions of weather. So look at
That's a
how
fascinating
much the prediction for tomorrow differs from what we actually experience.
Yep.
And see if people get upset because of that.
We actually have a project in the draft stages that's exactly that. We downloaded the historical forecast data.
Okay, awesome.
Because there's another question here, which is the degree to which it's kind of deviation from the forecasted variables that matters, not necessarily the deviation from the historical trends as well. So it's a very important and fascinating question.
For that, you might also need to understand where people are getting their weather forecasts from, because we know that the local news stations
You're right.
will bias,
Totally.
the probability of rain towards it raining.
Yep. And that NOAA provides different forecasts than Weather Underground's more local stations and things like that. Now they're still they're going to be pretty well correlated with one another, and that those biases are probably consistent. So to the extent that they are wrong, they're probably both wrong somewhat. Maybe not so much with precipitation, but with respect to temperature, my guess is if NOAA is off, then Weather Underground's probably also going to be off as well. I don't have evidence to support that yet, but great question.
All right. Well, thank you, Nick. This was fun.